So on the backside, based on this shape, this diagram, we're going to do a couple things. We need to find the area of the quadrilateral. And so to do that, we're going to break that down into finding the area of two triangles. The red triangle we have enough information for. Remember that formula we just used. If I know two sides and the included angle, I can find the area. So the area of ADB is going to be 1/2 times 7 times 11 times the sine of 110. So I'm not going to calculate that yet. That is the value that area will be. So in the blue triangle, what I noticed is I only have a side. So I have one of the sides. I have an angle. So that means I would need to know this side so that I know the two sides with the included angle. So if we go back to the red triangle, we actually need to do a little bit more work here. And we need to solve for that side. And in this case, we have to use law of cosines, right? So I have two sides and the included angle. So to solve for that side opposite, I can use law of cosine. So in this case, we have dB is the side I'm solving for, so squared equals the other two sides squared minus 2 times those two sides, and then times the cosine of 110. So it's law of cosines, right? So then remember, to solve this, I actually need to take the square root of that whole mess, and dB, right? So dB, that value is 14.92216.814. So if you need to practice that, go practice typing in that calculation. Otherwise, there's the unrounded answer, and I left it unrounded because I'm going to need to use that value a couple times coming up. This is a good unit to practice getting the habit of writing down the unrounded value. So at this point, though, we have that other piece of information, right? So we now know the second side in the blue triangle, and like before, so we can go ahead and calculate the area of BDC by taking 1/2 times 16 times my unrounded value, 14.922, so on, so on, so on, times sine of 40. So at this point now, I'm just making that calculation of taking the area, right, this value, and adding it to this value. So I end up getting 112.9124442. So the three sig figs, 113. And that is area, and our units are centimeters. So hopefully you guys can read that green. Not too confident about that, so there you go. 13 centimeters squared. And then kind of just an extension. So from this diagram, we want to find the measure of ADB. So this notation, the angle is the middle, right? The vertex, right? The middle vertice of that label is the angle that's being named. So that is ADB. So I'm just going to redraw the triangle ADB. And just highlight the angle I'm trying to find here is D. So once again, I have some information that I might be able to use. Again, I know this is 14.92 ... So now at this point, to find or solve for a measured angle D, again, you could at this point use law of cosines, but either way I do it, I have to use this calculated value. So whether I'm going to use law of cosines or law of sines, I like to use law of sines from here because I now have an angle side pair, and law of sines is a little bit more straightforward, I think. So to solve for D, angle D, I'm going to set it up with sine of D over the side opposite, which is 11, and set that equal to my complete angle side pair, which is sine of 110 over my unrounded value, 14.92, dot, dot, dot. Okay, so now at this point, I do need to solve this a little bit. So remember, you've got to multiply by the denominator. So we end up with 11 times the sine of 110 over 14.92. And then I still have to do the inverse, right? So the inverse sine. So D, the angle D, is going to equal the inverse sine of this whole fraction. So when you type that in carefully, and again, rounding to 3 sig figs, the measure of angle D, or again, we found it was labeled ADB, but the measure of angle D is 43.8 degrees, and that would be to 3 sig figs.